The next key characteristics that I'd like to discuss is offset. What is offset? The offset of a continuous futures determines whether the active contract is the primary, the secondary, the tertiary, etc. contract. So far in this notebook, we've been looking at the primary contracts only, which are the contracts trading with the earliest delivery. The second contract is the one with the subsequent delivery date. Tertiary is the next one. Let's just say we are right now in April. Okay, it's the primary contract will be the April contract. The secondary will be the May contract. The tertiary will be the June. This is with application to so-called crude oil. So let's just pull out the CME. And you can see this is like the crude oil futures quote. You have May, June, July. So this will be the primary, this will be the secondary, this will be tertiary, on and on it goes. And some of the characteristics that you can study is that you notice the volume is the highest here, and followed by these start to drop substantially. But as we move closer and closer to the so-called expiry date of the May futures contract, this volume will shift from here and to here, and this volume will pick up substantially. Okay, we're going to show you how to actually pull out the continuous futures with different offset. Here you have the offset being 0, here the offset is 1, and I'm going to print out the CL1 which relates to this, and then print out CL2 and which relates to the second one. And you will notice that offset equal to 0 here, offset is equal to 1 here. That's basically how you actually look at the actual so-called symbol that you put up. So if we want to look at the term structure of a particular future, what is term structure? Term structure basically is plotting the price versus the so-called maturity of the futures contract. This is the June, the futures contract that will mature in June. This is the one that's maturing in September, and on it goes. This is relating to S&P 500 E-mini futures. So we're going to do that with the crude oil and plot that. Let's pull out the pricing first. And what you can see here is that what are we doing exactly? We are pulling out 5. Okay, so from 0, 1, 2, 3, 4, and I will change from 0, 1, 2, 3, 4, and that will change our offset to 0, 1, 2, 3, 4. And with that, we're gonna pull out the price and the contract and download the daily pricing, okay, and store it into the variable called pricing. If you look at pricing, it's actually a panel. So you have two items, you have one major axis and you have 5 minor axes. What are these? This is where you look at the item of the axis, which is related to this item, is price to contract. These are the two things. The major axis is the dates, okay, and the minor axis is the continuous futures from 0 offset all the way to the fourth offset. Okay, so we're gonna pull out one date, which is 2015 May 5, and have a look at what this data frame looks like. So this is just on 2015 May 5th, and look at what the term structure looks like. This is the M contract followed by the N, Q, U, V, and you notice that the price is rising. So if we convert this panel into a data frame and change our index to the auto close state of the active contracts, and we plot that and see what it looks like. And basically this is what it looks like. Okay, you have the May followed by the June, followed by the July, followed by the August, followed by the September maturing futures, and you can see that it is actually upward sloping. This is also called a normal futures curve. It's upward sloping. It's normal because there's supposed to be storage costs, and in this case crude oil, it doesn't spoil. However, there's actually obviously storage costs, security costs involved with this. The futures 1 month later, the cost of storing these extra inventory has to come with the cost. So relatively, it should actually trade at a higher price than the current month. The next month, subsequent month should trade higher than the current month. And I want to show you an example of an inverted futures curve. And basically, we are repeating the exact same thing as the crude oil, except that we're doing it on E-mini S&P 500 this time. So if we run this, and this is what you can see here, is actually an inverted yield curve. The price actually is lower going forward. I won't go into explaining why there is a difference here. Part of it has to do with time value of money, but we're just going to leave that. Just basically the whole point here is to illustrate what an inverted curve looks like. So that's basically the end of this really simple tutorial. It's just really to highlight what a futures look like and Quantopian futures key features that is available right now in the Quantopian research platform. There are 72 US futures available, so there are plenty of room for you to play with. I'm particularly excited about this. They are going to add more going forward. There are many things that you can do with this, but for now, I'm going to leave it at that. Thank you for watching, and have fun with it.